Hey, hi Trish.
Good to see you.
Very nice to see you.
Hey guys, how you doing?
Rick, super nice to see you. Thanks for coming to ISC and our Intel booth here. I'm super excited to share some exciting news we announced yesterday with you, and thank you for your partnership. Well, let me tell you a little bit about why we're so excited about this event and why Aurora is so important for our scientific community. Being at ISC is really coming back to community, understanding and talking to them. The HPC community is very small, but impact of that community is humongous. Impact on our daily lives, the way they change our daily lives through simulations, through drug discovery, weather forecasting, financial analysis. Every aspect of our life is impacted by this community, and so I'm so grateful to that because, hey, we have to leave something for our kids, and we want to put it in the hands of smart people here. Second thing, Aurora is an incredible system. We announced on Monday that we broke finally that one exaflop barrier. That's super exciting. But also we announced that we are number one in mixed precision, about 10.6 exaflop of mixed precision. And that's important because modern applications will always use mixed precision to get best out of all the applications. And finally, Intel is all about open source, open ecosystem. We drive the open ecosystem because we believe that open ecosystem will drive innovation and differentiation. For that reason, I'm super thrilled to see the One API gaining traction with our community. Thousands of projects are actually on the way with One API. And Intel donated One API to the Linux Foundations last year under the umbrella of UXL. And I highly encourage everybody to watch the Andrew's Wright keynote today about the UXL and how UXL is changing, helping our customers to obfuscate complexity of a hardware focused on applications to solving the problem that matters.
Well, one of the really fun projects that we're doing with Aurora, right, it's Aurora GPT, right? So this is building a language model for science. It's trained on all kinds of data, biology, material science, chemistry, physics, and a lot of code. You know, generating code for One API, generating code for our GPUs, and this model is a partnership, of course, with Intel and with HP, but also with our friends in Japan and our friends in Europe. And that model is being trained right now on Aurora. And by the end of the year, I hope we have something that we'll release. It'll be really fun. And we're also trying to build benchmarks to really measure how much progress we can make in AI for science. I mean, that's a really strong target. But we're also doing other things. I mean, we have climate model codes running, material science codes, drug screening. We'll soon be able to screen over 1 trillion molecules in an hour on Aurora using AI accelerated molecular docking. And we've built an AI accelerated weather prediction system that just won the best paper in ICLR 24 called Stormer. It's really cool, but it's an example of this surrogate model. So it's HPC accelerated with AI, and it runs perfectly on Aurora. So lots of cool stuff. Just can't wait to just open it up to the whole community. One of the things that we're doing with the Intel team is working hard on optimizing the software stack for training large language models and for doing high-speed inference for large language models. So this is giving us a platform that not only we can use for training, but to do massive deployments for really interesting runs, right, where we can stand up thousands of inference servers and do something in like an afternoon that would take years to do, you know, analyzing millions of scientific papers like in an afternoon. So this idea of using Gen AI to not just answer questions, but to extract information from scientific data, hypotheses, and then look at a whole landscape of hypotheses, which humans have never been able to do before, right? We can, in some sense, look at all of science simultaneously on a machine like Aurora. So it's very, very exciting.
So one of the things we are really excited about is all of the science that you are doing on Aurora. I think I'm a huge HPC fan for years, and as AI enabled modeling and simulation, we are really going to be able to do at least 10x, it was 10 exaflops, 10 times, probably 100 times more science that we have ever been able to do. I mean, getting to now 2 exaflop machines in the United States means that we have so much horsepower to do this science, but also AI enabled and inspired science. So I think that we have the opportunity to really advance, and as we talk about, getting diversity into high performance computing, this will allow us to bring in, I think, more talent and excitement into this industry. I think the mixed precision just shows the ability to do 10 exaflops from a single exaflop machine, and I look forward to getting to 100 exaflops on the next machine.
Trish and Rick, thank you for sharing this interview with us. It was great to have you here. Please enjoy the rest of the show, and thank you very much for your partnership.
Thanks,
My
Augie.
pleasure. Thanks.
Yeah,
Thanks.
So what's really impressive about Aurora, it's the complexity of it, its sheer size. It's one of the largest machines on Earth. It has over 60,000 GPUs, 20,000 CPUs. It is the largest deployment of Slingshot fabric. It has an impressive brand new storage system with Deos. And again, it's a very well balanced machine, right? Both the compute abilities, the memory bandwidth, the memory capacity makes it perfect for the science it's made for. It's really a great collaboration across teams between Intel, HP, Argonne, with all the support that they got us. And so we really think that it's going to be a fantastic machine for the science that it's meant for.